Welcome to Trustworthy AI Chronicles, where we explore the cutting edge of AI security, ethics, and innovation. My name is Dr. Ihsen Alouani from the Center for Secure Information Technologies at Queen's University, Belfast. Join me to uncover the risks, share the breakthroughs, and spotlight the people shaping the future of trustworthy AI. Today, we are thrilled to be joined by Bartley Richardson, Director of Cybersecurity Engineering at NVIDIA. With years of experience at the intersection of AI and cybersecurity, Bartley is a leader in developing advanced solutions for securing AI systems. In this episode, we'll dive into his insights on the challenges and opportunities in AI security, and explore how NVIDIA is pushing the boundaries of innovation in this space.
Hi there, Bartley. I hope you're having a good time in Belfast. Absolutely. It's my first time in Belfast. Thanks for having me, by the way. First time. I've experienced, I think, 3 of the 4 seasons thus far. So I'm just waiting for the 4th one. But I like it. I love the climate. Almost as much as I love the people. Everyone's so nice here. So thank you so much for that. All right. So let's start with a quick introduction, Bartley. So your role in NVIDIA now as the Director of Cybersecurity Engineering. NVIDIA is known pushing the boundary of AI and technologies in general. Can you please walk us through it? Talk us a little bit about your career path and how did you get there actually? Sure. It's a non-traditional path, I gotta tell you. All right, like I can't recommend it to anybody. But it's nice, and the reason I like to talk about it is because there's so many different ways to get into various different careers, right? Like especially in security these days, like you don't have to come from a quote traditional security background, right? And in some or in a lot of cases, it's advantageous, right, to have a diversity of backgrounds working in security. So I started out my undergrads in Comp, and that's the last time that I really dealt with hardware hands-on, right? So if there's a quiz about hardware architecture, I'm going to fail it. And then my PhD is in theoretical computer science, specifically query optimization for loosely structured and unstructured data techniques, and logical optimization of that, which nobody wants to talk about. And then I spent around 9 years as a CS professor in the Midwest in Ohio, and before moving into government. So then I went into work for DARPA in the U.S. It's the DRD's Advanced Research Projects Agency, and that was my first introduction to cybersecurity. Really, DARPA's a bit unique. It's somewhere in the intersection of government and academia, right? And so they brought a bunch of PhDs from all different aspects, economists, physicists, political science. I was the only computer scientist there. And they put us in a room and they were like, go solve cybersecurity. And this was 2014. Like, and I don't want to spoil the end, but we didn't do it, right? We didn't solve it. But it was fascinating. And that's why I'm talking about the career path is so interesting. And there's so many options to be in that environment where there's so many different people coming at the problem, but all had like a quantitative background as part of their PhD. So if we're talking about like economists that are coming in with their techniques, their skills, right? Like their perspective, even their analysis, their tools they're using, and then mixing with physicists, and we're talking these things. And so it was a great environment for that. So I spent some time there. I moved into to some other parts of the U.S. government, where I led some projects around critical infrastructure. So IoT, commercial, industrial IoT, and safety of those systems, SCADA, BACnet systems, that type of thing. And then went to NVIDIA after that. I went to NVIDIA to help start something that we now call Rapids, which is our accelerated data science stack. And we always envisioned Rapids as a cybersecurity application, because when we think NVIDIA is a bit, we fancy ourselves a bit like academics. We fancy ourselves a bit like, DARPA, where we like to boil things down to first principles. And when we're thinking about cyber, we think about massive data problems. And so, been there since 2017, 2018, gradually grew out the cybersecurity program, and here we are now. We have a lot of different trusts for cyber, both on our product lines, hardware and software.
Absolutely. That's fascinating. I wasn't aware that you actually hopped somewhere at the Daba before going to industry. And I wasn't even trying to ask you about this, but I had guests with the two hats or the two perspectives, academia and industry. You're probably the first that you have actually three perspectives that you went through: academia, industry, but also a government agency. Can you please give us here, if you look like zoom out and see and tell us what is really that you enjoyed most, or the perspective that you gained from those three environments?
Yeah, that's a good question. There's always positives and there's areas for improvement in every environment that you're in, right? I think the one thing that has been maybe a constant thread is I've always enjoyed research, but it took me a while to understand that I really enjoyed more applied research. That I did my PhD was all theoretical, was all math based, right? Because I at the time hated programming, hated it so much, and so I decided to avoid programming. I was just going to prove it all mathematic.
Yeah, as abstract as possible.
Exactly. If I can prove it to you, I don't have to. Who cares about the? Yeah, exactly. But so then, moving, I kind of, well, I'm sure you and everybody else, you know how it is in academia, you get down a research path, and then sometimes it's hard to switch that research path. So I did bounce a little bit around in research paths in academia before landing on, I think I kind of like this thing, that if I could do it and actually put it into practice, that would be useful. Moving into government, and DARPA is a little bit unique in that space, in that not everything has to do what we call transition. Transition means it makes it into like a product or to a branch or to a service or something like that. But that was always the goal. The goal was always to transition. So we looked at it much more applied while we're talking about these concepts, like how do we apply topology concepts to cybersecurity. We always had this lens about but then how will we apply that in real life? And then kind of took the next step, and then at NVIDIA, there's an arm of NVIDIA called NVIDIA Research. That's not what I'm in, and they do a lot more foundational and fundamental research. But I have one of my teams is an applied R&D team that does AI modeling and new types of things there. And that's really the common thread that I found throughout it, is I really like this cutting edge, what's around the corner, but then how does that get into an actual application that people can use it?
That's very interesting. And I guess the fact that you went through DABA before getting to industry helped, because as you mentioned, it's more about transitioning some conceptual elements into practical solutions. So that's fantastic. So NVIDIA is known probably first as a hardware company, and I guess that's inherently what NVIDIA is, but also software and AI and so on. From your perspective as leading the cybersecurity engineering, what is your perspective on this intersection between hardware, software, and AI now?
Sure. I think definitely classically and historically, if you were even go back maybe 2.5 years, if you ask people at NVIDIA, they'd be like, "Oh, hardware company," or they might say gaming company, as well. Right? Ask your kids, right? For older people, you're like, "What's NVIDIA?" I'm like, "I'll ask your kids." Well, no. What we found though is, if anyone has used in the past, things like CUDA, we found that in order to take advantage of the accelerated compute that we provide, and that's how we would kind of describe ourselves, as we're an accelerated computing company. In order to take advantage of that, you had to go through a lot of hoops. You had to learn this thing called CUDA. It was sometimes difficult to program. It was difficult to hyperscale out, right? There's always networking. And so if you look just even the last 3-4 years, what we've done is we've started to move up the stack, where now instead of CUDA, you were able to program directly in Python, and have Pythonic applications that they give you the same benefit of programming directly in CUDA kernels. But you could be a data scientist, or you could be a regular developer that's looking to harness it. You didn't have to work for a national lab or understand how to do hyperscale. And so as we'd added this software layer, and we could talk a little bit more, we get deeper into it, what we're doing on the software side of the things. It was kind of a natural progression where we already had the underpinnings of CUDA. I mean, we were already working, to compile. We were already working on secure architectures, right, in our GPUs, and we can talk about things in our new CPU lines, like the confidential, confidential computing and the secure enclaves, right, that we have there. And really, we envision this as, if we're talking about the relationship between it, is if I abstract it just a little bit more, there's these two pillars that we talk about. And one is securing AI. And that is a combination of both the hardware that you're running on and then the entire full stack software that you have. And then there's this other pillar, which is AI for security.
Yeah.
And we're very interested, we're obviously interested in both. We're very interested in how do we apply AI to help security. And then there's this feedback loop between the two, where we will implement, secure techniques, in our chips and our software, or secure around them. And then that enables us to then say, okay, now we can harness this accelerated compute in a secure environment to provide additional horsepower, additional analytic value on it, which then goes back into securing that whole system, whether that be a chatbot or a agentic system these days. So we see it as not just the interplay between the software, the hardware, and the user, right, or the designer, but also the interplay between, okay, how are we securing AI, and then how are we using AI to help us in that task, whether it be chip layout or whether it be software stacks.
Yeah, that's fantastic, actually, because but I have been discussing with colleagues and members of the community and guests of this podcast about the role of hardware in the big picture. Even though people might not think of hardware when they're talking about AI, at the end of the day, it's going to be some code running on hardware. And having the hardware perspective on security and securing also the hardware, that, as you mentioned, as a part of the stack, is, I think, fundamental. Yeah, that's so now. Those two pillars that you mentioned, and that's exactly what's probably this podcast is about. AI used for enhancing or helping or solving cybersecurity problems, and the security of AI itself. So let me ask you this first question. From your perspective, what does NVIDIA do to ensure that the deployed AI models are robust, safe, secure, whatever?
Yeah, no, it's interesting. I like how you separated safe and secure, right? I think that's very good. It's a very astute thing, right? A lot of people, or many people, kind of conflate those two terms, right? And they are very different terms, right? Like there's security, and then there's safety, and some things are the responsibility of, might be, depending on the application, might be the responsibility for the application designer, right? Like, when does an AI model that has been deemed safe turn unsafe, right? Like, and depending on the application, is that security concern? Is that a safety concern? So I just wanted to say that I like that. I like that part because not a lot of people conflate those here. So there's quite a few things, if we think about the hardware side of the house, one of probably the newest thing that we do in our new CPU, Grace, right? We have this thing called a secure enclave. And it's part of our whole thrust on confidential computing. It allows you at the hardware layer, right, baked into the chip and as a chiplet to do things like you can store a model encrypted, and you can keep that model encrypted during inference. You can keep that model encrypted, at rest. You can implement privacy securing or privacy policies, right, like on the data flowing in and out of the CPU. Because if you look at the interplay of the GPU and the CPU, right, like traditionally what you do to get data into the GPU is you round trip that through a CPU, right? That trust those PCIe does. So we can take advantage because we control the lanes between the CPU and the GPU with our architecture, right? If we're talking to ML, Grace Hopper or Grace Blackwell. We could take advantage of that secure enclave, and you can program it just the same way and have access to, implementing CUDA kernels the same way that you would do anything else, right? Like inside of that. If we, another thing, if we talk about hardware for just a second, is our networking, mind, right? So we typically call things either ConnectX or Bluefield. And Bluefield 2 and Bluefield 3 have cards that are available and not just have the ARM processor, we call it a DPU, which is a data processing unit, on it, but they have the option to be there's a SKU that we call a converged accelerator card, which has the DPU ARM chip on it, as well as a full-fledged GPU on the NIC itself, right? And you can get them in like extremely powerful configurations. You get like an A108 gig GPU on the NIC. Oh, it's a totally overblown NIF, right? So it's a full high double slot 250 watt card, right? But it's got this full power GPU on it. And the reason I bring that up for security is, again, when you're bringing data across the network, a lot of times the ways you get it into your system is you burn it through your PCIe bus and you bring it to host, you make CPU. You can run these converged accelerator cards in what we call embedded mode, which means that the DPU controls the GPU directly on the card. The host doesn't see the GPU at all. It has had no access to it. And so when you're having data coming across, like let's say you've got this hooked up to like a VM and you've got all these different, or you got this up to a hypervisor and you've got all these VMs running on it. You can do things on this DPU, and with the GPU attached, you can read memory, right? Like directly from it. And you can do analysis directly on the card without ever sending that data off the card and do a round trip in it. And so there's those types of security things that we do on the hardware side. I'll move over to the software side for a little bit. We've recently announced these things that we call NIMs. It doesn't actually stand for anything. It's just NIMs. They're called NVIDIA NIMs. And what we do is we take we have our own models, but we take community LLM models. So think like Llama 3. There's embedding models like Arctic from Snowflake, and we take those models and we not only optimize them for all of our hardware SKUs, but we go through and we ensure that we are pulling the correct model from the Neva, right? Like we've encrypted this model, we have verified and we've digitally signed this model. We've optimized it through TRT for all of our hardware SKUs. And then we make that available for developers in a very lightweight container that is both OpenAI and OpenAPI compatible. And the net of that is we realize that, look, and you get the enterprise. Your developers are going to use this model, right? Like whether you make it easy for them or not, they're going to use this thing. And so we wanted to provide an option that's like, okay, if your developers are going to do it, how do you permit this concept of shadow AI, right? Like as much as possible. And it's like, let's give them an easy way to drop it in. Okay, so instead of going to Hugging Face, like we love Hugging Face, you can get any model off Hugging Face. You could go and grab a NIM, drop it in. The API compatibility is exactly the same that you're used to. And you know that we pay attention to the whole software supply chain. We guarantee security patching and CVE mitigation in that container as well. And we update that monthly. And so we do things like that on our software side as well for our developers building applications on these models.
Oh, very interesting. You mentioned actually twice encrypting the model. What do you mean by encrypting that?
So you can take, it doesn't even have to be like an LLM model, right? Like you can do whatever model. And with the secure enclave, you can keep those model weights. You can keep that model essentially encrypted at rest. And then when the data is coming through, there are ways where you can, fully.
So it's a homomorphic?
Yeah, they all blend conversation. And so you can then keep that encrypted. You don't have to be encrypted. We use it, primarily the modes, I think, primarily the way we see it instantiated or used in practice today is in federated learning.
Yeah.
Right, where you can have these models, you want to train them, federated, I think healthcare, right? You've got hospitals, various places, and they might have a very rare type of disease that each hospital might see 4 times or 5 times, but they still want to pull this data, but they always privacy concerns, these data transmit concerns. So we can keep those models encrypted and implement federated learning. We call it ND Flare, right? Like NVIDIA Flare, yes, or federated learning thing. Yeah.
Interesting. So the continuing on the AI side, so you have NVIDIA has the different inference server, which is basically to streamline the AI development. So how does this address the challenges that you mentioned and to ensure the trustworthiness. And the reason I'm asking this is that while having some abstraction layers from the developer, making the developer's life easier from a security perspective, as a security person, I tend to be paranoia if you want to have. So say, oh, I don't see anything here. It's totally abstracted and lots of things might happen. So how do you ensure you streamline things and making things easier? How do you ensure that it is still trustworthy or secure?
Well, I don't think you'd be a very good security person if you weren't a little paranoid, right? Like, you have to have a little bit of paranoia in you, right, to be effective in that. So I don't begrudge you the paranoia there at all. So there's a few ways, like you mentioned Triton. So Triton can do a lot of different types of model serving, right? Like it doesn't have to necessarily do LLMs, right? You can serve, traditional machine learning models in it as well. Triton is delivered one way. A Triton, we employ a lot of open source software, right? So NVIDIA's very, if you'll be CUDA's closed source, but a lot of stuff we do nowadays is open source software, right? So that's one way that we try to ensure at least a bit of visibility, right, like into the software. When we're talking though about modern AI and LLMs, if I go back to these NIMs, they actually don't include the Triton engine, right, like inside of them. They are optimized directly in TensorRT and TensorRT LLM, which then does a couple things. One, it removes the somewhat heavier weight Triton inference server from your pipe, right? Because let's say you got a system and you got 5 different LLMs in it, right? Like you have 5 different instantiations of Triton, right? Like inside of it. And so it's a lighter weight ways to inference directly in TRT LLM, and you can observe all of that inside the container with like telemetry logging and observability and all those types of things. Triton itself, if you're using Triton, again, is instrumented. You can, if you want to log that through OTel or Prometheus, you can log at any different level that you want, like inside of it. We have different ways, to whether you're curating data or whether you're fine tuning data. There's different, I'll call them products that let you do that, and some of them also are built on top of Triton. So if you're thinking about like things like Nemo Data Curator, right, and all this data that you want to curate for an LLM model or something like that. We have methods in Data Curator that will, for example, look for PII, right? That if you're putting data into it, but that's in like a PDF or that's in plain text or something like that, you can extract out the PII. And we're really big on giving choice and plugging into where the community's at. So if you want to use, like, regular ways of identifying PII, right? You can absolutely do that. We have our own models that we've developed, our own small language models. I'm honing in on PII just as an example, but we have our own small language models that we've also developed to identify other types of PII, whether it be credentials or keys or all these types of things. And all those spoke into a system that maybe sits on top of or encapsulates a little bit of Triton, right? So Triton, think about that as like more of the workhorse of it. If you're using Triton though in a more traditional machine learning application, you had to actually boost model or something like that. Really what you're doing then is piping in all of that telemetry, OTel, Prometheus logging directly into whatever your observability platform is. We also have our enterprise offering of all our software is called NVIDIA AI Enterprise. And with that, we also build out examples of how, okay, you want to use Triton and you don't want to give it your credentials, so you can add sidecars onto it, right? Like you can add this like single sign-on sidecar, right? Like onto it as well. And so then it can hook directly into your vault with your credentials, and you don't have to worry about credential management in Triton. It just becomes a part of your regular credentialing system.
Yeah. So another tool I wanted to talk to you about, or platform actually, which is Morpheus. I guess you're leading on this as well. And technically that's what embodies using AI for cybersecurity, correct if I'm wrong. So what are either Morpheus or whatever, even in general, what are the cybersecurity problems that you managed to solve? Even though solving a problem in cybersecurity is a fuzzy concept, but it helps, like, say, mitigate problems efficiently using a
Yeah. Yeah. Well, I think our grandkids, right, will be solving cybersecurity problems, right? Like you're making it incrementally better, right? Well, you best put it this way. If we want to solve it, like, if you have an idea how to solve it, let's just go, make a $1 billion later, have a unicorn start. No, it's a good point. So, one thing I mentioned earlier is data. And there's really, I can give you two kind of examples on different sides of the house, one more traditional, one more recent. One is we took the concept of user behavior and we just exploded it, right? And traditional user behavior really looks at your traditional sources of identity and what are you passing through your, what's either coming through your SIM or what's coming through your firewall logs or your Active Directory logs or your two-factor logs for all these in the types of traditional modern system, which is great. But the analogy I give is it's like if an alien came and was up in the sky, right, or whatever. And they want to get a complete picture of Bartley. They only look at Bartley between 9 a.m. and noon every Tuesday and Thursday. Like, it's not a complete picture of what I'm doing the rest of the time, right? Like, I'm not doing anything interesting or in there. But, what we've done then is because of our accelerated compute engines that we have and the hardware, we can open the aperture out to say, okay, not just this data. Let's print all this data in from Lava. Let's also bring in everything you do on Confluence. Let's bring everything you do on Jira, everything you do in our build infrastructure, right? All these other things that show that would be, tipping and queuing typically, right? If I was not who I said I was, even though I have partial credentials. And we can do that modeling on a per user base, a per service base, a per machine base, a per application base. And it uses as little as 4 A100 cards, right, to do it for a 30,000 person, company like NVIDIA, which is incredibly efficient, right? Like sometimes I worry, I'm like, oh my goodness, it's too efficient, right? Like, how are we going to sell more GPUs, right? It's too efficient. So that's one example. The other example is more recent, and we really think these agentic systems, complex agentic systems, are going to have immense value in cybersecurity when architected, with a fabric of security themselves, right? And we can talk about that as well. Just if for no other reason that they give humans and they give analysts this incredible superpower to analyze data so much faster. So we've implemented this one that we call Agent Morpheus, which is all about CVE analysis. And what it does is, in a nutshell, it takes all of the data integration, the analysis, the summarization. It takes all that onus off the individual security analyst, and it accepts, security scans and SBOMs and documentation and containers. It generates its own checklist. So it's like, okay, I've got these scans, I've got this container, I know about this code. What are the steps I need to do to ensure that this is safe to publish, that maybe a vulnerability is there, but it's not exploitable because we've mitigated it in code, right? Like, of course, you always want to bump to the version where the CVE doesn't exist. It's not always possible. You get stuck in these weird dependency loops where you have to backport software. And so it not only does the work of analyzing the checklist, there's actually an element that we've fine-tuned to generate the checklist in the first place, right? So it's like, okay, here's what you need to do, system. If we do the agentic loop, which is this perceived reason act loop over and over again, get a summary out. We align that summary to a VEX justification that goes to the analyst, and the analyst can expand it. They can see the whole conversation, right? In quotes, they can see the whole conversation if they want, and then they can make a decision based on it. And what I'm most proud of in that system is the team has done such a good job at getting this LLM, the summary LLM, to say, I'm not sure. Which is very hard. They're so sure of everything, right? Most of the time, they're very convinced that they're right, and when it's not able to make a decision, it fairly reliably says, "Hey, I'm not able to make that determination." But human, here's the steps you could take to make this determination, right? Like, which we think is a great outcome. And the other reason I like that use case is if we talk about traditional AI and you think about like cybersecurity anomaly detection, right? Everyone's always concerned about the false positive rate, which I get because there's millions and millions of events and how many to triage, right? This is a totally other side though, because the alerts, the CVEs that are coming out of a regular scan, the human has to look at all of them, at least all the high-end criticals. So if I reduce it by 40% or 50%, that's still better, right? Like it's not solved, but it's better. And that's where I think the power of these agentic systems are going to be, right? Like they don't have to solve 100% of the problem, so at least not right now, but they reduce the workload and give the decision maker, the human, the CEO of this scenario, that capability.
Very interesting, and I think that that's exactly the type of help to a specialist, which is scalability in a sense, because sometimes, as you mentioned, systems are huge and events and flags come from all over the place. I mean, I can imagine SOC analysts having this tool making definitely their life easier. But now let me push back, if you want, a little bit, sir. Don't you think that having those more sophisticated systems make the analysts lazy in the sense of it's getting it right, and even if it is not unsure, the system would say I'm not sure, but still I guess from accountability perspective, if something goes wrong, it's still the human who is responsible, not the tool. How do you envision this risk of people over relying on an ML model? Either you say, okay, let them over rely, it's gonna be getting it anyway, but definitely somehow, somewhere, something is gonna go wrong.
Yeah.
And still it's the human who is responsible.
Absolutely. You know, and that's so that's very important, right? You know, obviously part of it's going to be a little bit of education, and I come back to that part. But you know, there's a very real part of it that we're very cognizant of. You know, whenever I told you about it, you know, I talked about all the great things that we do. When we talk about our partners that are building on it, and we talk about it internally, one of the key things that I stress with the team every single time is you have to be transparent and intellectually honest about what the capabilities of this thing are and what the pitfalls are. Cybersecurity, and I'm speaking for all of us in cybersecurity now, historically has been an over-promise, under-deliver for AI, right? Like we put AI on the box of everything for years now, decade, right? Like this is AI, and it's like, this is AI, yes, that, right? Like, and so I feel for the cyber community because we've been burned so many times, right? Like on this, not singling anybody out, because I think everybody's guilty of it, right? And that's where now that we have these new systems that are meant to kind of alleviate and give the analysts these superpowers, I think we have another shot at transparency and being very intellectually honest about what this system is, because people look at it differently, right? And that's what we do. So we talk with our container analyst team, and we're like, look, we're going to onboard these software products into it first. You're going to give us feedback. And then our data scientists and our modelers we embed them directly with them. And they're like, oh, how is this model performing? We're very clear that we're keeping this in parallel with all of our other tools, right? Like none of that is going away. It's providing a layer on top of that. And we add, you know, that kind of extra, I don't know if you're gonna call it accountability, but we add that extra forcing function as like, look, you really have to look at this, right? Like, and we almost bias it to being the system to being too safe, right? Like to being like, if it has the choice, you know, if we had the choice, we'd be saying like, yep, good to go, or nope, not sure. We'd bias it towards no prop sure, right? And so some of it is that, the transparency aspect. And then we spend a lot of time in education with not just our own teams, but if we're helping, you know, another company implement it or take it, spend a lot of time educating them. That's like, look, you know, here's what you can expect out of it. Let's walk through your data feeds and do these types of things. And here's realistically how many analysts we think you're going to need, what they need to know, right? Like, and how they need to be like retrained. And then also at the same time, trying to extol the benefits of once you have them here, we need to now, you mentioned the point about like, getting stuck in a rut or getting a bit lazy. It gives us the ability to upskill these analysts, right? Like a little bit. If we alleviate some of their time, you can get them from tier 1, tier 2 to tier 3, tier 4. And I think that has to be part of the equation, right? Like we're not just going to be like, okay, this part, good, you get to click the button right anymore. It's like, no, you get to maybe click the button and do some analysis, but then we're also going to add to your skills, your critical thinking, security skills as an analyst.
Yeah. So in this kind of threads of discussion that we touched a little bit about transparency and accountability, let me go back to your first example about the use of AI for cybersecurity that you mentioned, the behavioral analysis of a user. Don't you think that from an ethical perspective, there is a risk of surveillance with this concept?
Well, I think, one thing that I think is true regardless is any attacker tool can be used for defense, and any defensive tool probably can be used for attack, right? Like it's this constant cat and mouse gaze, right? Like, and so I think there's risk in any of those systems that could be used for anything. Where I think we have a bit of advantage is, it's when you're implementing it, one of my sayings that I tell people is like, it's not magic, it's math, right? But it's not magic, it's math. And so you do have to have pretty reliable and high fidelity data, at least in part. Because when you're doing this unsupervised type of machine learning, your assumption is that most of this is good, right? Like, typically your assumption is most of this is good, or most of this is at least not non-nefarious, right? Like at best, like there might be some errors and that kind of thing. So the amount of high fidelity data that you have to have would require obviously some type of nation state to have, a collection type program. And then we're talking about whole other scenario there. Am I thinking that like, oh, company X or company Y is going to be able to do this and then find out things about you? Maybe. But I don't think any more than what they can find about you from advertising on your both device, right? Is there more? I don't know that makes that more efficient. What it does though is it lets us, at least as a company that owns all that data, right, like on the network, be able to get intelligence value out of it.
Oh, absolutely. So, Bartley, I think what we are witnessing now, I guess, there is some disruptive innovations that happened in the last couple of years. Seeing forward, and obviously we can definitely talk about all the positive, very useful things that can come out of this, and that's obvious. But let me continue in the guardrail of say, as a whatever perspective of, do you think there are actually leaders of the community, including like founding fathers as like Joshua or other people who think that, look, there is even people thinking of existential risk and things like that. Obviously, there are also leaders of the community thinking like Young Lincoln, for example, thinking of that's not a thing. Hey, just stop it. What are your thoughts in? Are there any serious beyond the discussion, the discussion about the existential threat and so on, but even in general and any societal risk of these models getting more and more sophisticated and used more mainstream on the general public?
Yeah, awesome. Well, I probably, I'm not biased at all at anybody, but I probably fall into the more camp of like, there's just immense amount of usability on it. Obviously, I will answer your question. The example I give, which is maybe a bit flippant, but I love it, is we've been working a lot on how do you get data from like a PDF from a structured image, like a chart array or a graphic somewhere there. And one thing that's really hard is if you have a graph and you have these minor vertical lines and they overlap with the number 5, the models, it's so hard to get that to realize that that's not a dollar sign. Right. Like, and so when I tell people, again, somewhat flippant, when I have like just casual conversations with family, like, oh my God, AI is going to take over. I'm like, I will be worried about it when it can tell the difference between a 5 and a dollar sign. Right. I'm like, right now, I'm good because it's very confused by that. But I do think that it is a risk that we see. You know, there's like, we have to acknowledge there's a very real risk that we see. I think not so much in the Terminator, we're going to watch like news things, but there is this ability, this almost like a commoditization of the ability to generate very authentic looking data and algorithms, right? And whether that be video data or audio data, you see it all the time in the US. We have the Biden robocalls, right? And all these types of things, or text data. And so the risk is, one of those risks is, I think we all are aware of it, is what's real, what's factual, like what can you trust, you know, those types of things. And there's quite a few startups, and there's quite a few like large cyber companies really taking this seriously, and they absolutely should. Like, you know, NVIDIA, not a cybersecurity company, but from all we produce, but we work really closely with these companies to help enable them in their mission to do that, right? So if we look at, you know, deepfake analysis, there's really good companies that are doing quite a lot of work in being able to detect in real time, like, hey, is this audio, you know, faked or something like that. There's policies, right? And policies on their own are not gonna solve everything, and regulation on its own will not solve everything, because it has to be a layered approach. But I see that more of as the risk is we have this great ability. You can generate images on your phone, and you can generate all the cat pictures you want on your phone. It's just fantastic. But then you turn that to the Taylor Swift, the Biden, you know, all these types of things, and it provides a real risk to government, to, you know, normal operating problems. So I think the way you mitigate that is, again, multifold. There's these new capabilities, right, that will obviously that are obviously in flight and coming online all the time. There's always going to be an education component, and as I don't like to classify myself as a recovering academic, right? Because I still do like part of that, but as an academic, right, at least, there's so much we could do to educate so much of the community about this, and how do we push this lower in our education systems across the world, and how we use these systems, and how critical thinking doesn't get to go away, right? Because we have these new systems. There's that component of it. And then there's the technology component of how can we, you know, people talk about watermarking and all these things. And again, none of these are the single approach that's going to solve all of this, but the culmination and the ensembling, right, if you want, of all these things, help mitigate that, I think.
Yeah, that's very interesting. And I think the key element you mentioned is critical thinking. And I had a discussion with many colleagues about, students that are going to be using ChatGPT as well. Well, let them use it. As far as we just need probably, just is not a appropriate word here, but we need probably to change even our paradigm of education, probably to focus more on critical thinking and giving them the skills actually to think beyond the potentially tasks that can be automated. Let them be automated, and let them challenge them more in a higher intellectual level. And I think that's from an education in universities, but it could be general, letting the people access to, or helping people having more critical thinking.
Well, yeah, and just to add on to that, right? Like, it's just, obviously we've had this sleep, right? Like some people call it like the iPhone moment, or this is the early days of the internet, and all this stuff is happening. And just, I think it's very similar to those, where like if you go back and look at, I went back and looked at some of the I don't know, papers, but articles about like when like calculators become like wired. It's like, oh my God, like how is gonna, I know this is different than calculators, right? Or it's different than like computers were used. But I do, to me, growing up, being a big Star Trek fan, right? Like, and all these, this is the promise of Star Trek that was always given, is I'm the human, I can go to the computer and I can ask it to synthesize data for me, and it produces a Star Chart for me, or it produces some text for me. And I'm like, oh, okay, I understand that, right? Like, now let me ask a follow-up question. Is that actually real, right? Like, can I trust that particular sensor? And I just think we have to get from there to there. And part of that's on us in industry, and part of that's on education, pushing that all the way down, right? And that's going to take a community effort. Sure.
Absolutely. But I have probably one last question on this thread, and then we'll have to close. The perspective that you have from industry, specifically from the US perspective, which is just the overall environment in the economy and innovation wise more liberal in the sense of regulations. How, from your perspective, see the EU AI Act as a regulation framework, and specifically to be more technical than philosophical, the risk-based framework, and how do you see even the idea of regulating? And second, what do you think about how useful or not this effort in regulating?
Yeah, I think there's, and full disclosure, right? Like, not a lawyer, not even politician, right? Like, so definitely not even a good or a bad politician. My thought about regulation and kind of standards in general, which I tend to lump together, one being more firm than the other, right? Like, is I think is some version of that is going to be useful, right? I think some type of standardization, some type of enforcement of that standardization via regulation is going to be useful to the community at large. If we liken it back to other types of regulations that we have around either like food labeling or safety or all these other types of things. I see it as a way to enforce transparency, right? Like
GDPR upwards.
Yeah, exactly. Consumer protection, right? Like, and we have versions of that in the US, depending on what state you're in, right? Like, has a bit more disjoint, right? But we had that, it's different based on other states. And I think that's really great. I think, the parts of the regulation that are enforcing that particular transparency and being like, look, as the industry, we generate things like model cars, system cars, and blueprint cars, and all these types of things. But enforcing that transparency to the user, look, this was made with this was trained on this data, or even going back and saying like, I think the user, and now I'm taking off my NVIDIA hat, just putting on my CSIT hat, right? Like, I want the option to be like, I don't want my data to train this particular model, right? Like, or I don't want this to be able to do. Enforcing those types of things, I think, is great because it gives the user and gives the user choice, right, there to do that. It loops back into the education of the user, right? Because think about how many EULAs have we clipped through, right? But that you probably realize, well, who knows what I've accepted, right? And let it click through, right? Because you get bombarded with them. But I think there will be a place for that, and I think what's coming out of the EU is a great starting point, and will obviously be iterated on, and different countries will take parts of that, and I'm sure there's a lot that we can all learn from that.
Yeah, absolutely. I would love to continue on this because also the challenge, let me say about this is that the technology is moving fast, and I'm not sure. I don't think a regulation needs to change every 6 months because the systems are changing. I don't think it can. So exactly. And you have regulation, and then you have to create some standards to have this tell companies, okay, now you need to comply with this technical requirements, which is a little bit challenging. But yeah, I guess that's a part of the equation as well, and it's probably changing the paradigm. Let me close with this question about do you want to mention any in the closing thoughts, any specific upcoming project that you are excited about, or any wave or how that you want to mention, or any thoughts or advice?
Ollie, what can I plug? No, I would mention two things. As of what is today, the 4th, and today is the 4th, October 4th.
Yeah.
We're having NVIDIA's having an AI summit in Washington DC next week. So that would be the 9th, 10th, or 6th, 7th, 8th, right around Monday, Tuesday one. Whenever this goes, it probably will have happened, but the content will be all there on our website. We have some interesting announcements in our blueprints. which are our ways to take and in an open source way show people how to use these NIMs, these large language models, in an actual pipeline, while also incorporating things like guardrails and all these other types of things. So we want these blueprints to be, oh, here's an inspiration for how you could use this, not only to accomplish some really cool tasks that you want to do, but some automation. And that's my other saying is, I'm like, everyone talks about AI and AI and AI and what defines AI. And I tell them, I'm like, you're never going to be able to define it, because the minute you trust a system or trust something implicitly, it ceases to become AI and it becomes automation, right? Like, so your definition of what AI is always changing. So we have these blueprints that we put out to say, like, look, we have this really cool thing that you can use to automate this task. It's AI. Here's how you would actually implement it. Here's what the architecture looks like. That we've thought about security in the fabric of the architecture, and here's a way you could do that. You change it if you. So some of those, we come up, look up AI Summit in DC as this was happening a week later. We could talk more about that. But that's really good. And then the other plug is not NVIDIA specific. The other plug is, we need a lot more people thinking about both of those pillars, right? Like, and coming from varied backgrounds. I take it back to like my time at DARPA and how we saw all of these academics and industry professionals like coming together. So I would encourage you, I encourage everybody, if they're interested in this, but worry like, oh, I don't have a security background, or I don't have this type of thing, that shouldn't be a blocker for you, right? Like, we would welcome you into our community, and your perspective into the community would be amazing. And so one would be look up AI Summit in DC, and then two would be like, please join us.
Brilliant, fantastic, couldn't be better. Thank you very much. Thank you for your time, buddies. That was fantastic having you. Thank you.
Thank you. Very good.